All right, pre-cal, in this video, we are still in Unit 7, but now we have gotten to topic 3. So we're going to be solving trigonometric equations. So if you'll notice, when you scroll down here, all of these equations have a trig value in them. So that's why they're called trigonometric equations. So this is going to be a little tricky because you're going to have to solve these in two parts. You're going to have to first isolate the trig term like you would if you were solving for x or any other variable. You would have to isolate the trig term on one side of the equation. Then we are going to use the unit circle to evaluate what that would look like. So there's a couple of different kinds of problems we're going to see here. The first ones we're going to look at are the ones that tell you to find all solutions or all of the possible solutions for a given trigonometric equation. But some of them will have restrictions, like on these down here. Okay, so some of these have restrictions. This does not have restrictions, so we'll talk about that here in just a moment. All right, so as you're looking at this, I have added the unit circle over here so I can refer to it easily, and I won't take up as much time on your videos. So on number 1, find all solutions for sine t equals 1/2 in degrees. So we have been told that we need degrees, we need our answer in degrees, and we're finding all of the solutions. When I talk about all of the solutions, I mean all of the possible solutions for every possible rotation of the circle from the value that you get here, okay? So that's what I'm talking about. All right, so I want all the solutions for sine t equals 1/2. Well, for this particular problem, our trigonometric expression is already, or our trig term is already on one side, so I don't really have to do anything to this algebraically. So I'm ready to go with this. Sine t equals 1/2. So the question you need to ask yourself, at what degree, see, because my answer is in degree, at what degree is sine equal to 1/2? So I am going to look at my unit circle and remember that the second term is sine. So if you'll notice, sine is 1/2 right here and sine is 1/2 right here. So at 30 degrees and at 150 degrees. So I know that all solutions, t is going to equal 30 degrees plus 360 degrees n, where n is an integer. That means it can be a positive or negative value, so it takes care of rotation in the positive direction and in the negative direction. The other solution, of course, is going to be at 150 for all rotations of the circle, so 150 plus 360 n. Okay, because you have to go all the way around the circle to get back to that value. All right, so that's how we're going to do these. So let's look at number 2. Find all solutions. So I'm going to have to add something once I get to my solution. So I'm going to find all solutions for cotangent A equals 1 in radians. This one is going to be a little bit tricky. We do have it already in the form we need. Cotangent A, I've got my trig term isolated on one side. So I need to ask myself the question, at what radian is cotangent going to be equal to 1? Well, if you'll recall, when we're talking about tangent and cotangent, we have to consider the fact that cotangent, remember, cotangent theta is equal to cosine theta over sine theta. So that means this value over this value, all right, cosine over sine. Well, the only place that cosine over sine equals 1 is going to be right here and right here, okay? It's not going to occur here or here because those values are -1, because your sine is negative in quadrant 4, your cosine's negative in quadrant 2. All right, so this is occurring at 2 places. Notice the 2 places that it's occurring are right across from each other. So technically, for cotangent and tangent, since their period is only 180 degrees, as we learned in the last unit, we only have to rotate 180 degrees to get to the next value. So A here is going to be equal to pi over 4 plus pi over n. Now, I want you to see why. Cotangent is 1 right here, and that's at pi over 4. I'm writing it pi over 4 because I was asked for the solution in radians. Since I want all the solutions, I have to account for all the rotations. Well, if I rotate pi, which is 180 degrees, half the circle, then I get to the other value, which is 5 pi over 4. And then when I rotate again, I get back there. So I only have to consider one of these. And it doesn't really matter which one you write. But remember, n is an integer, and that accounts for all the positive and negative rotations of pi to get my answer. All right, let's look at number 3. Number 3, I have to manipulate algebraically a little bit because remember, your first step is always isolating the trig term on one side. So what I'm going to do is I am going to write this as 2 sine A, and I'm going to subtract the 1 from both sides, and then I'm going to divide by 2 to isolate sine A on one side. Okay, so sine A equals -1/2. Now it looks just like 1 and 2. I just had to do a little bit of math first, do a little bit of algebra. I want my answer in radians, and I want all the possible solutions. So I need to look at my unit circle and figure out what radian measures have sine A as -1/2. So I'm going to go to my unit circle. I'm going to erase all this. So on my unit circle, sine is -1/2. Well, this occurs right here, and it also occurs right here. So if I'm measuring in the positive direction here, that's going to be 7 pi over 6 and 11 pi over 6. But remember, these are not right across from each other, so I have to consider all rotations. So A is equal to 7 pi over 6 radians plus 2 pi n, all the way around, remember. And then the other answer is 11 pi over 6 plus 2 pi n. That is how we write our answers. Neato.